So here we have a VCR. Back in the 80s, this is how we watched memories and recorded our movies. You know, and developed a library of different forms of entertainment. We'd watch them on just a normal television set. And the connections to this were really simple. By connecting what we called composite cables to take care of the video and both of the audio feeds going from the out. And just as simply, the video and the two audio and the audio video in to the television set. Of course, in the 80s, we didn't use these flat screen televisions. We had more of these tube TVs. Took up a lot of space and were less likely to be stolen if anyone broke into our homes. But the question is, how do you get something like this onto something like this that would be able to be read on a normal computer or laptop? So what I'm going to show today is my technique into bringing the best quality of video, converting the best quality of video to digital format. This is not the technique that most people use, just to let you know. There are simpler ways of doing this, but this is what I do in order to get as close to broadcast quality with 35, 40-year-old footage. So step one, let's look at the equipment. This is the Sharp VC-H800. Now, it does have a sharp picture feature on it. It says SVHS quasi playback, but it is not a SVHS deck. If it was a SVHS deck, such as those that come from JVC, a lot of these steps that I take would probably be unnecessary, to be honest. It's a 4-head VHS. It's a pretty good running machine. Most people at this point would then be looking into going into a video capture device. And then that video capture device would go into a computer. And that computer would have software associated with that device to record the footage. But my system here, I mean, it lies on a totally different way of thinking concerning video capture. So let's bring in an orthodox device to help us with capturing video. This is the Philips DVDR3475/37 DVD Recorder. This is what I call a problem-solving machine. We are not going to use the disc features in this machine. These kind of machines are more valuable for the other features that they offer. Let's take a look at this front panel here. Look at the front panel here for a second. In there, you have your standard composite cables for video, audio, and the audio feeds. It also has an S-video in with it. And looky here, particularly with this unit, it has a DV in jack, which those who have digital cameras from the early 2000s can put in their camera without, say, a FireWire card on the computer and record the picture. It's not as good, but that feature is there for solving various problems here in the 2020s. And here is the back. You have composite in, another composite in with S-Video, but these are outs. You got composite out, you have component out, and there's your S-Video out. You also have an HDMI port that goes out. Now that allows you, if you connected the VCR to this machine into the composite outs, and then you put an HDMI in there, and you have a way of capturing HDMI, which we'll go into here in just a moment. This job can be done right now. What that HDMI out does is it converts that composite out feed to 1080p. So most DVDRs are pass-through machines. What you put through, you also get put out without using the DVDR disc features. All you need to do is put a signal into it, and through those back jacks, you'll get a signal out of it. Sometimes they might need you to go into the menu settings. This machine in particular requires you to choose either between S-Video and standard video input, and you get to that through the menu settings. But besides stuff like that, this is very it basically does the work by itself. Let's get into the connections. So there we have the composite out from the VCR, currently going to the television set here, correct? Take off the audio, take off the video. Now we could just do something like that and be past the first step. But we're going to do something different here. We're going to be looking at that S-Video. So here we have an S-Video cord. So say, plastic notch on the bottom. I think that's in, because we're going to use that instead of this. Well, we have a problem. And that's what this guy is for. It goes from composite video to S-Video, the female end. And I'll have to put the phone down again. I'll put that in there. So why use S-Video instead of composite? Well, S-Video is to separate the color channels from the black and white channels better, I guess. And it also provides a little bit of detail would be kind of my word for it. And so I really like using S-Video. So that should give us our best composite picture to go into the DVD-R. Okay, so looking at the back jacks. And as I was saying before, we could always go out using the composite. You know, even the S-Video with the audio, giving us the best picture possible. Okay, one other thing I can mention about this Philips DVD-R. It has a feature in it that's similar. It isn't technically the feature, but it's similar to the feature. It kind of mimics the effects of what is called a time-based correction, a TBC. You know, it mimics TBC equipment in its ability to stabilize video, and that's why I really like using this machine with a VCR. You know, a lot of people that go from the VCR directly to capture software. Well, with it the VCR shows a warped picture, and technically with that, if like my VCR showed a warped picture on the television set, the time-based correction feature in this device is able to take that out, and it can stabilize that picture, making the picture better than what you see on the television set. Okay, back to connections. You know, at this point, we could go through the HDMI out and attach to another HDMI device to give us a 1080p picture based on the analog. It actually has a couple problems. The first problem is it's going to stretch the dimensions of the picture from 4:3 to 16:9. That's number one. Number two, even though it upconverts it, by blowing the picture out, you know, into a higher resolution format, doesn't necessarily sharpen the picture. I mean, it can. If you go through the software VLC, you can use the effect settings, and sharpening the 1080 picture will sharpen it better than a 480 picture. But if we went through that HDMI out at this point, it's going to dirty up your image. It's the best way I can put that. It's going to add edges to stuff that's there. It's kind of the effect of a snowstorm is the way I kind of think of it. So technically, we want a 480p picture coming out of this Philips, but we don't want to use composite. That will actually kind of blow out the picture, and it will make it fuzzier than what we want. If we want detail, as much detail as we can get off of 480p, we want to use component. And that takes care of our videos. It has to be green, blue, and red. And we also want the audio. Now my audio cable here has a yellow head. I apologize for that. I don't mean to confuse people with that, because that's going to go into the red audio jack. So what then are we going to do with this? So as this says, this is a component to HDMI scaler. It's an up converter, video converter, up 1080p. It's made by Tendak. Now, all of these devices are not created equal. See, I also have this device. You know, and like this one, it's got component cables on the back. It's got component cables on the back. Got an HDMI output on that. Got an HDMI output on that. But this device here not only puts out a softer and less detailed and less well lit picture. In fact, some of its brights are more blown out. This puts out what you put into it. If you put a 480p image into it, it'll output a 480p, albeit through HDMI out as well. This is an upscaler. This turns it from a 480p component video to a 1080p component video. But I'm also going to say something kind of confusing here, and I apologize for this. We are not going to use this to upconvert, because when we upconvert 480p 4:3 dimensions, it stretches the image out to 16:9. So we're going to output 480p out of this. But again, this gives us a more detailed, because it's got the features in it. It gives us a more detailed picture than this guy. This guy, we're going to do the same thing, but this blows out whites and it gives a softer image. We want the picture that the Tendak gives us. So there we go. We got the cables connected, and we got an HDMI cable connected. So now we can start looking into connecting this to a computer. This is Elgato's CamLink device. These are actually kind of hard to find now, but Elgato does have an updated version called CamLink FK. So, so it's more high definition, and even the software is better, and you got a lot more options. But this works for our purpose here. It goes in through USB, right? USB 3.0, by the way. And then it's got an HDMI jack right there. So you put the VML in there and you're good to go, right? Okay, so we got it going. I do have to mention that if you try going through the HDMI on the Philips and you tried connecting it to the CamLink, it would give you an HDCP error in this game capture software that's made by Elgato. And in order to deal with that, you have to get like this 2x1 splitter made by this company called U9, and it should take out that error. So, can I see that? It's kind of hard to see, isn't it? Basically, that information that shows there, it shows that that's at 480p, 30 frames per second. Let me show you what happens if I take the settings on the Tendak and I change the resolution. And suddenly, the image is stretched out 16:9. It does that by 1080p, 60 frames per second. (1080p, 30 frames per second). (720p, 30 frames per second). The only one that works in the correct framing is the 480p. Okay. So Elgato has got software on their website that shows the camera as well. This is game capture software. This is not that camera software. This is the one that you want, because if you right click here, it gives you that ability to exit or enter full screen. It also gives you that option to hide the sidebar. So watch this. Hide sidebar. And look at that. You now have a full screen image with the Elgato software. Now, for some reason, the Elgato software does not allow me to record this image to my hard drive. But that's okay, because we have an option. And it's actually a better option because it saves on the resources on the computer. So on my laptop over here, I have an HDMI out. We're going to use that to capture our video. So there we go. We got that HDMI connected to go out. So where are we going to put that? This is known as the ezcap HD video capture device. It is a standalone device that allows you to put in an HDMI in, and then you're able to plug in a USB in there, card, and record directly to the card in brilliant HD. In fact, it's almost faultless HD. It doesn't even look like it's being compressed. It looks really good. So we've come full circle. We now have our disc in the little adapter there to go into the USB host. We've got the HDMI in, of course, and then we've got the HDMI out going to the television set. Everything is framed properly, 4x3. And in order to get our analog footage from the VCR to this, we just have to push record. And now we've got a high definition rendering of our analog footage going. Now this guy cost me about $60. I got the DVD recorder online, eBay, for about 60 bucks. The VCR I think cost me about 120, if I remember right. The Tendak cost me about 30, I think. Cam links can be kind of expensive. They can be well into the 100, like 150 or so, if I remember right. So the setup, it's true. It ran about 170, 200, 260. This ran me about 400 bucks for this setup. But it's worth it for being able to catch analog the best I possibly can.